Okay, and now for history of human exploration of the deep sea. First up, we have the HMS Challenger, which sailed around the world in the 1870s. Also, fun fact, HMS is an acronym that stands for Her Majesty Ship. So, Her Majesty Ship, Challenger, was the very first oceanographic expedition. It provided an incredible amount of information about the marine environment, like mapping the seafloor bathymetry, which is the different depths of the ocean. It also collected samples, both abiotic and biotic. Abiotic are things that aren't living, such as rocks. And then biotic are things that are living, such as corals and fishes. Okay, so the HMS Challenger collected these samples using rope. Rope. How would you like to lower rope off a boat miles down? That seems very challenging. Okay, next up, the bathysphere, my favorite. The bathysphere was the very first submersible, and it was lowered. It's a hollow steel ball that was lowered by a chain. A little bit more advanced than a rope. However, I don't think that I would feel comfortable being lowered in a hollow steel ball off a boat by a chain just over about a half a mile. Okay, next up, modern technology. We have ROVs, which is an acronym that stands for Remote Operated Vehicles, and HOVs, another acronym that stands for Human Operated Vehicles. So the difference between a ROV and an HOV is that ROVs, this bottom picture right here, is actually attached by a cord, an electrical cord called an umbilical, to the mothership, which is the ship that the ROV flies from, and it's called flying. It could be called swimming because it's in the ocean, but we call it flying for some reason. I guess that's a little bit more fun. Okay, and then an HOV, this top picture up here, is a submersible that is not attached to a mothership. It has no umbilical. It's completely by itself down in the deep sea. It's being flown by a pilot, a human pilot sitting inside the HOV, as well as two lucky scientists that are able to see the deep sea in real time and real life. Lucky them. Okay, so an ROV, a remotely operated vehicle, are a little bit more abundant than HOVs. However, there are still only a handful of them in the world. They are incredible pieces of equipment. They are super high tech, very heavy. There's a lot of amazing equipment pieces on them that I will get into later. So this ROV is named ROV Hercules. Just like ships, ROVs and HOVs have names. This is HOV Alvin. It's owned and operated by Woods Hole Oceanographic Institute, also known as WHO. So as you can see, this HOV is not attached to the mothership whatsoever. It's being flown down in the ocean by itself with a pilot, a human pilot inside, along with two scientists. Okay, moving forward. Okay, so here are a few research / exploration vessels that I've been lucky enough to go aboard. First up, we have the RV Western Flyer, which is a catamaran. Cata means two, maran are these holes right here that go into the water. So this is a catamaran so that it's able to lower a super heavy ROV, super heavy piece of equipment down deep into the ocean while still staying balanced. So the ROV is dropped from the middle of the boat in between those two holes. So this particular vessel, the RV Western Flyer, is owned and operated by MBARI, which is our local marine institute. MBARI is an acronym that stands for Monterey Bay Aquarium Research Institute. Next up, we have the RV Sproul, the research vessel Sproul, that is owned and operated by Scripps Institution of Oceanography. And then this picture in the middle right here is of RV Reuben Lasker, owned and operated by NOAA. And then we have the RV Oceanus, which is owned and operated by the city of San Diego. And last but not least, we have the EV Nautilus. So looking at these names, what do you notice that is different about this name? It's that it's called EV. EV Nautilus, not RV. So RV stands for research vessel, while EV stands for exploration vessel. So the priority of this vessel is to explore. And in that, the EV Nautilus prioritizes communication with the public and the outside world. So thanks to the EV Nautilus, a lot of people in this world know about the deep sea in general. So the EV Nautilus takes wonderful pictures. They explore amazing places of the deep sea, and their priority is to get that cool information out to have people fall in love with the deep sea. Okay, moving on. So there are 4 cutting-edge deep sea research institutions: the Monterey Bay Aquarium Research Institute and MBARI, which I just talked about, that owns the Western Flyer, that awesome, cool catamaran. And then we have Scripps Institution of Oceanography, where I went to school. It's my favorite. And then we have Woods Hole Oceanographic Institute, also known as WHO. So Woods Hole is on the East Coast. It's kind of like Scripps's rival. And then we have the National Oceanic and Atmospheric Administration, also known as NOAA. NOAA. So these are the 4 main research institutions in the US that conduct studies of the deep sea. All of these institutions own a fleet or a group of research vessels. Some of these vessels come equipped with an ROV or a HOV. All right, so here is that Western Flyer, and there is the ROV that I spoke of earlier that they drop down from the middle of the boat. And the name of this ROV is Doc Ricketts. Doc Ricketts, owned and operated by the Western Flyer. All right, and then over here we have the EV Nautilus that comes equipped with ROV Hercules. ROV Hercules. And then as you can see, there is a whole lot of technical equipment and material that is tied into this ROV, which I'll get into in the next slide. Okay, so ROV and HOV appendages and instruments. There is a arm and a claw. There is a slurp/suction appendage. Also, these ROVs and HOVs have video cameras so the pilots can see what the ROV is seeing. These ROV and HOVs also come equipped with sensors, such as a salinity sensor, temperature sensor, and a pH sensor. There's also a sediment core sampler, and there are compartments to store samples. So the purpose of these compartments is so that scientists can orchestrate the pilot of the ROV to put whatever sample they're looking at into a designated box. So let's say we're down 3 miles deep and we collect a super cool part of a coral. And then we tell the pilot to put that super cool part of a coral into box E6, box E6. And then we write in our notes, this coral was collected from this depth in this environment. And then when we pull this coral up to the top of the ocean, then we know exactly what sample we have retrieved. So here's that slurp mechanism, which is essentially a vacuum. Here is the claw that I spoke of earlier. And then here is that arm. So the arm is kind of like our arm, whereas the claw is kind of like a human hand. So then the claw is able to grab a hold of that slurp mechanism and orchestrate where it goes precisely. So let's say we see a super cool worm on that substrate, which is actually a different type of worm. Those are giant vestimentiferan tube worms that are ecosystem engineers for other species. Okay. Next up, we are slurping up a sea pig, which is a type of deep sea cucumber. The scientific name for this is a holothurian. So here we see the claw grabbing a hold of that slurp mechanism. And those two green dots are lasers so that we know the length of these samples. Got them. Got the second one. So these are called sea pigs. Oops. All right. And then here on the left, we are slurping up a deep sea anemone. Got it. And then on the right, we have a video of the pilot's room. So this is where the ROV pilots fly the ROVs, and the scientists are sitting in this back row right here, watching the ROVs collect their samples. We're also telling the pilots what we want. We want that sea pig right there. Okay.